We are continuing polynomials, so we've learned how to add and subtract and multiply and divide polynomials, which was our last two quizzes. And so we are moving into factoring polynomials. And you have factored a polynomial before. If you remember the x method, so the x method is a specific way to factor quadratics, which is a type of polynomial. They have exponents. That the highest exponent is 2, it's a degree 2. So you do know how to factor quadratic polynomials. Now there's lots and lots of polynomials. You know, we have cubics, quartics, all those fun ones we just learned about. So we are going to learn 4 strategies, 4 methods of solving polynomials. So we will use the x method a lot. We will use some newer ones. But we have 4 methods, which is a lot. 4 methods that we need to make sure we're good, we know how to use, and we know when to use them. Today's going to feel a lot like a review. The first 2 methods we are going to go over today is factoring polynomials in quadratic form, which we know how to do, which is the x method. And then we will factor using what's called a common monomial, which is a lot like a greatest common factor. And later this week, we'll use long division to factor, so we did learn long division for a reason. It helps us factor. And then finally, we'll learn factoring by grouping. So these are the 4 things we need to know. We'll go through them one at a time. Okay, first one, flip your page, is factoring polynomials that are in quadratic form. Okay, now this is, for the most part, a review. This first method is, for the most part, a review. Now, the big thing to know here is that x method, the a times c on the top, the b on the bottom, and then we find our factors on the sides. And this is from earlier in the year. We can use the x method whenever there are 3 terms. Okay, whenever you see a polynomial that has 3 terms, you will probably be using the x method. So if we look at this little review, we have 1, we have 2, we have 3 terms. Whenever you have 3 terms, it is a good indication that you will probably use the x method. Now, you won't always use it, but usually 3 terms means the x method. Okay, so let's do it. So, blast of the past. When we are using the x method, the first thing we need to figure out is there a greatest common factor? So if I look at 5, 19, and 12, is there any number I can divide 5, 19, and 12 by? There isn't. And that's because 19 is a prime number. The only number we could divide them all by is 1, which we don't need to do. So that means we're going to go ahead and do our x method. So let's figure out what our a, b, and c are, because a, b, and c is what we put into our x method. What is my a? My first coefficient is 5. My b value is positive 19. And my c value is 12. Okay, so hopefully this is starting to ring a bell. Once you have your a, b, and c, it's time to draw our x and follow everything in our x method. This looks crazy, but it's really not that bad. We draw a nice big x, and we start following our rules. In the top of our x, we have a times c. So we're going to multiply what is our a value times our c value. So 5 times 12 will give us 60. Again, that was our a value times our c value. In our x method, that came from right here. A times c. 5 times 12 is 60. Our b value just gets put on the bottom. And our b value is 19. So we take the 19 and we write it down below. The last thing we need to do to set up our x method is we need to make sure that we divide both sides by the a value. So right here, divide both sides by a. So we do over and our a value is 5. We need to make sure we divide both sides by 5. Okay, so this is our setup. A times c on the top, 5 times 12 was 60. We put our b value on the bottom, our b was 19. And we're going to divide both sides by the a value. Our a value is 5. The hardest part is finding that p and the q. Those are your what's called factors. These right here are the answers to factoring a quadratic. To find p and q, we need to find two numbers that follow two specific rules. The two numbers that go on top of both sides, they have to multiply together to give us 60, and they also have to add up to the bottom. So those two numbers have to multiply to 60, and they have to add up to 19. So maybe you did save your cheat sheet that has your factors for 60. A good method is off to the side, making a list of numbers that multiply to 60. Okay, so if we make a list, we know that 1 times 60 is 60. And again, we're making this list because we know our two numbers have to multiply to 60. So if I can make a list of numbers that multiply up to 60, I'll be able to find which one adds up to 19. Okay, what else makes 60? 2 times 30, right? That makes 60. We got 3 times 20. Okay, we got 4 times 15. And we got 5 times 12. And 6 times 10. Okay, you might be like, okay, well, how am I going to find all these? Well, either one, you use that cheat sheet from earlier in the year. Second, if you take your calculator out and just start dividing 60 by a bunch of numbers, you can generate your own list. Oh, 60 divided by 1, 60 divided by 2, 60 divided by 3. You can make a big list. But here are all the ways to make 60. Which means one of these ways has to add up to 19. So we're just trying to figure out, well, 1 plus 60 is 61. Can't be that. 2 plus 30 is 32. That's not adding up to 19. 3 plus 20 is 23. Until finally we get to 4 plus 15. What do I get when I add 4 and 15? Well, I get 19. So that's my winner. 4 plus 15 is 19. And 4 times 15 is 60. That means those are my winners. Okay, so I put a 4 and a 15 on the left and right side. Okay, that's the hardest part. So this left and right side are what's going to help me get my factored form. Now, before I write down my factored form, I need to make sure that these fractions are simplified. So earlier in the year, we learned that if I take out my calculator and, for instance, type in 4 divided by 5, I can click Math, Enter, Enter, and it will simplify the fraction for me. If you take out your calculator, type in 4 divided by 5, Math, Enter, Enter, you should see that 4/5 is already simplified. 4/5 simplifies to 4/5, so that's going to help me find one of my factors. On the right side, I can do the same. 15 divided by 5, and click Math, Enter, Enter. The math button's in the top left of your calculator. When we simplify this fraction, we get 3. So this left and right side are going to help me write my factored form. Okay, so let's remember what factored form looks like. Okay, factored form is always 2 sets of parentheses. Okay, they always have an x in the front. And now we use the left and right side to write our factors. So the easy one is 3. This is a positive 3, so I just put plus 3. There's one of my factors. Now for 4/5, fractions are a little tricky. I don't want to just write plus 4/5 because I don't want fractions in my factored form. So we're going to take the number on the bottom, which is 5, and put it in front. And I'm going to take the top number and do what I did with the 3. This is a positive 4 on top, so plus 4. And this is my factored form. So that polynomial, that quadratic, is factored, okay, using our x method. Okay, so this is what we did earlier in the year. This is the first method of factoring polynomials. Is if there are 3 terms, you always want to try and do this first. Okay, let's go to example 1, right? Okay, example 1. Let's give it a go. When you look at example 1, you look at it and you're like, okay, this is a polynomial. We know it's like quadratic because what's the largest exponent?
Could you go back up for a minute?
Yep.
I think I missed something.
When you look at number 2, or example 1, you should be like, oh, there's 3 terms. And my largest exponent is 2, which is a good indicator that I'm going to use the x method. Okay, again, because there are 3 terms, and our largest exponent is 2, which means it's a quadratic, that usually means we are going to use the x method. So what is our a, b, and c here? What number's in front of that x squared? 1. So that's a is 1. My b is, careful, positive or negative 16? Negative 16. And c is 63. Okay. Now, why didn't I ask if there was a GCF this time? Can there be a GCF when one of your values is 1? Nope, because you can't divide 1 by anything. Okay, so here's our A, B, and C. So we draw our X. Up on the top, we have A times C. 1 times 63. 63. Our B value goes on the bottom, negative 16. And we're going to divide both sides by A. The A value is 1. So I need 2 numbers that multiply to 63 and add up to negative 16. Okay, so let's make our list. What are some ways to make 63? Well, 1 and 63, of course. I don't think 2 times anything is 63. 321. 7 and 9. And that's it, right? That's it. Now, this is interesting, though, because 1 plus 63 is 64. 3 plus 21 is 24. 7 plus 9 is 16. Now, that's really close, but what do they need to add up to? Negative 16. So what can I do to both sides so that they still multiply to positive 63, but add up to a negative number? Yeah, I can make both sides negative numbers, because what's a negative times a negative? Positive. But now when I add negative 7 and negative 9, you get negative 16. So this time my winner is going to be negative 7 and negative 9. Okay, let's simplify our fractions. Now, it's nice when your A value is 1, because what happens when I divide something by 1? Yeah, it's just going to stay the same. So negative 7 and negative 9. But you could always type in negative 7 over 1 and use that math enter, and it would simplify it for you. So all that's left is writing our factored form. So draw your 2 parentheses. Put your x's in there. And we just put in the left and right numbers. I'm going to have x minus 7 because it's negative. And I'm going to have x minus 9. And that quadratic, that polynomial, is factored. This is factored form. We can stop right here. Factored, factored. Would we like more of those factor sheets tomorrow? The ones with the list of all the ways to make each number? Yeah? Okay. We'll print some more. What do we got? Two more? Two more. Example 2. Can I divide 2, 17, and 21 by anything? I always want to try to take out that greatest common factor. You can only divide 2 by 1 and 2. 17 can only be divided by 17. And 21 can be divided by what? 1, 7, 1, 21, 3, 7. So this has no greatest common factor, so we're going to go again. Starting with our A, B, and C. What is A? 2. B is, and C is 21. Beautiful. Draw your X. Okay, take a second. Fill out the X. A times C on top. B on the bottom. Don't forget to divide both sides by whatever A is. Hey, what did we put on top? A times C was 42. And what do we put on the bottom? And this time, what are we going to divide both sides by? Beautiful. Okay, now the fun part. We need two numbers that multiply to 42 and add up to 17. So, okay, what are the ways to make 42? Always 1 and 42. 2 and 21. 3 and 14. 6 and 7. Here's our ways to make 42. And again, you could generate your own list by checking by dividing. If you don't have your cheat sheet from earlier in the year, we'll get some new ones tomorrow. But which of our pairs is going to add up to 17? 3 and 14. This is the only pair that multiplies to 42 and adds to 17. 3 and 14. 3, 14. If you're wondering too, it doesn't matter which side they go on. If you put 14 on the other side and 3 on the other side, that's fine. Now before we write factored form, we need to check and see, can we simplify these fractions? So 3 halves, can it be simplified? Nope. If you do 3 over 2 in your calculator and do math enter enter, it's still going to be 3 over 2. Although 14 can be divided by 2, that simplifies to 7. Now we have everything we need to write our factored form. Draw our 2 parentheses. Put your x's in front. The easy one is positive 7. We can just put a plus 7. 3 halves, again, is a little tricky because I don't want to write plus 3 halves. What number do I write in front of this x? The 2, the bottom number. 2 goes in front. A positive 3 goes at the end. And our polynomial, our quadratic, is factored. Factored, factored. All right, one more of these before we kick it up a notch. Example 3. What number is in front of this P in the middle? A 1. If you want to write in your 1, it helps you write down your A, B, and C. Okay, so A, B, C. A is and c is negative 18. There's our ABC. ABC. Okay, draw your x and fill it out. Does the x method feel easier the second time around? Hopefully. A times c on the top. This is a big one. 5 times negative 18. Negative 90. Negative 1 on the bottom. We're going to divide both sides by 5. Alright, so this time we need to multiply two numbers together to get negative 90. We'll just make a list for not positive 90 first, and then we'll figure out what to do with the negative. So, ways to make 90. We always got 1 in 90. We got 2 and 45. We got 3 and 30. 5 and 18. 6 and 15, and one last one. 9 and 10. Okay, but right now our list is actually not quite correct, because these are both positive numbers, and those would multiply to positive 90, which means one of my numbers should be a negative number. Now, a good way to figure out which side should be 90 is by looking at the bottom. If the bottom number is negative, then the bigger number should be negative. If the bottom number is positive, then the bigger number should be positive. So since the bottom number is negative, that means all of my bigger numbers should get a negative. That's because when I add two numbers together, if the bigger number is negative, then my answer would be negative. So let's look through this list. Which of my pairs will add up to negative 1? 9 and negative 10. 9 plus negative 10 is like doing 9 minus 10 is negative 1. So we got 9 on the left, negative 10 on the right, although if you flip-flop them, that would be totally fine. Okay, take out your calculators. Does 9 over 5 simplify? It does not. This is just 9 over 5. That is already a simplified fraction. Negative 10 over 5 simplifies to negative 2. And we're ready to write our factored form. Put your x's. The easy one is our minus 2. We just minus 2. How would I turn 9/5 into a factor? Where's my 5x plus 9? And this polynomial is factored. Great review. X method is extremely helpful and will be used in a lot of the other methods we're going to learn. But this is your first thing you got to know. You got to be able to know, hey, this polynomial has 1, 2, 3 terms. If your polynomial has 3 terms, then you're probably going to use the x method. Okay? That is our first method.